Hello everyone. For this video, we're going to talk about association rule. Now, what is association rule? Association rule is a type of rule-based machine learning technique that is used to discover relationship, patterns, or association between all such large data set. Now, if we consider a data set, we talk about all the items inside it. We talk about the features inside it. So, in association rule, we take those item sets and find some relationship between them. Like for example, we have grocery store data where we have milk and bread as an item set. Okay, so we have seen in many feature or in our item, whenever it's like this ki, if we are buying milk, then we are definitely buying bread, or either it could be, if we are buying bread, it could we also buy milk. That is what is supposed to be association rule. Okay, so we are finding a relationship between both of them. We are connecting points, that if we are going for this, then this will happen because of it. Okay, so for example, consider a grocery store data set where milk and bread frequently appear together in a transaction. Okay, so we know that frequently it will appear in a transaction. An association rule might be milk bread, indicating that customer who buys milk are likely to buy bread as well. So I have already told you that if we are buying milk, and it is highly likely that we would buy bread also. So this would help us get a valuable insights about our business or about the data set, about that what could help us in knowing our customers well, that for their needs, that if they require this, we could conclude that yes, this could be another thing that might be needed to fix this. So yes, it could help us in improving the marketing strategies and enhancing customer experiences. Through this also we could, here we have there is a code to how to mine association rule using Python. Okay, so import pandas as PD for, so we have imported all the, you know, um, modules here, and we have created a data set. Okay, data set which has milk, bread, eggs, bread, butter, jam. You can see here we have created a data set, and for every way, obviously this is a categorical data set. So we, for every categorical data set, you must encode them into a binary, or you could say a numerical value, because it helps us with our analysis more easily. So this is how we would encode them, like TE is equals to transaction encoder, so that it could be easier for us uh, to handle all the categorical values. Then frequent items. Now through how would we know the frequent items? Okay, that how many times we are getting the milk, how many times we are getting the bread. So for that we could use the frequent item through a prior method. So this would we would use find frequent items using a priori algorithm. So we have created the frequent items, then we generated a rule, generated association rule, and finally displayed the frequency item set, and with that we could conclude frequency item set that you can see here. The support an item, like support is uh, what is support? Actually, support is the number of times uh, an item set has occurred. Okay, so bread has occurred 0.8 times, and butter has occurred 0.6 times. So this is how the support is generated. Then we have the association rule, that we have antecedents. I mean, antecedents means if it is happening, then the if part, if we are buying bread, then consequent means if we are buying bread, then obviously we would buy the butter too, and that's how we would calculate the antecedent uh, support and consequent support. Also with this we would just uh, work with support and confidence to get our association rule that we have generated here, that for every every bread and milk there would be an support and consequent support. Okay, so seeing this, we have obviously considered a threshold value. For you can have your threshold value so to get your desired association rule. Okay, next is uh, next is support and confidence. I have already told you what is support. Support is the number of frequency or occurrence of a particular item set, that if we how many times bread occurred, how many times butter occurred, how many times milk occurred. So that is support. Confidence is the strength between both the items. I mean, when we had I mean to say is like when we had milk and bread together, when we had bread and butter together, that is confidence. I mean the strength between the two items. Then we have antecedent and consequent. In a rule of the form A, A A is the antecedent and B is the consequent. The rule suggested that if there is occurrence of A, that is associated with the occurrence of B. So if we take occurrence of bread, it is associated with the occurrence of butter. So uh, uh, if we buy bread, then it is highly likely we would just go with butter too. Next is um, confidence quotient criteria. Now, what is exactly confidence quotient criterion? It is a refinement technique applied to association rule in the context of association rule mining. It is used to filter or select rules based on quotient or confidence antecedent support. Okay, so um, where the addition of signal, I mean there is a confidence between them, right? So we have the rule focuses when we add an item to the add an item, then the antecedent significantly increase to the support of antecedent alone. It allows user to refine the set of rules to choose where the association is more meaningful and impactful. Now see, if we add bread both the time, okay, so this could help us. I mean, you have seen like a person went for bread or butter, next next another person went for bread and milk, another person went for milk and butter. So you could find that there is a occurrence of milk, bread and butter for the time being. Okay, so when they're adding the items, I mean it could items like milk or bread, the antecedent that if milk happened, the it would significantly increase our confidence relative, so that we could come to a conclusion that if we have milk, then we will surely have bread too. Okay, so for the if we consider the code for that, um, here is it. Again, we have a data set, milk, bread, the one we were using for association rule. Then again, we did the encoding and encoding. Okay, so obviously categorical values, and for that we have encoded. Then we have frequent items. Obviously, we have to generate the support of the data set, and then we finally would generate our association rule. Now our threshold here was 1.5. Okay, we gave a threshold of 1.5. It could be anything. The confidence question threshold could be anything, any desired value. Okay, and when we put a threshold value, we would generate a filtered rule. Like rule would be rule confidence divided by rule of antecedent support, which should be greater than confidence quotient threshold. This we have applied our confidence quotient criterion so that it could help us in managing our criteria. Okay, so after applying that, we would print it filtered association rule, and you could see here that we had the filter association rule, that you could see the antecedent consequent, the supports, uh, respective supports of them, and then we have the actual support, the confidence, and through that we could come up with it as filtered rules. Okay, so all in all, this was confidence quotient criterion. Okay, next we have confidence difference criterion. Now, what exactly is difference criterion? The confidence difference criterion is another refinement techniques used in association rule mining. If you're talking about association rule, it is a significant feature. It is supposed to be there to filter or select based on the difference between confidence and antecedent support. The goal of the confidence difference criteria is to focus on rule whether the addition, I mean, if we add item set, does it significantly impacts our antecedent support or not? I mean, if we are adding it, we should get a value, right? That every time a customer gets bread, it should it should create another impact on our data set. Okay, so so for that, we just go for confidence difference criterion, that if we have these such item, then for that we could associate it with another item and create a association with between them. It allows user to identify rules whether association is strengthening or weakening. We would get an idea that if we always take bread with butter or not, so that we could uh, tell that if there is bread, then it would always have the butter. Okay, so it would strengthen it or weaken it with time, with customer purchase. Okay, so, when implementing confidence difference in practice, users typically experiment with different threshold values to select rules that meet their specific criteria of significance. Okay, so when we are when we experiment with the confidence difference criterion, we use different threshold value to get our selected rules. I mean, we would set another threshold value so that we could easily meet our specific criteria for significance. Okay, so this is how, this is what confidence difference criterion is. If we talk about the code, and let's go. Here is another how to apply confidence difference criterion using Python. You can see we have learned for our, you know, modules. Then we had the data set again. Then we had the encoder, obviously to for categorical values. Then again we had the support, filtered uh, filtered values. Then we had the rules, and then again we applied a confidence difference criterion. We had a threshold value for it, which was 0.2, and then we generated the filter rules. So where we could see here that the rules of the confident rule and the rules antecedent rules should be less than our confidence difference threshold to get our filtered association rule and printing filtered rules. Here you can see here that we have printed here, okay, and that's it. That's it for our confidence difference criterion. Okay. Next is you have all. Next is our multi collinearity. What is multicollinearity? It refers to a situation in which two or more independent variables in a multiple regression model are highly correlated with each other. In other words, it is the presence of strong correlation among the predictable variables. So, just like the last one, we know that multicollinearity refers uh, refers to both the items. Okay, we have item sets which are like, it could be one or two, or it could be more. So we find correlation. I mean, there is always a correlation between two features. Okay, so here you can see there. Suppose you are building a regression model to predict a person's height. Okay, so we had a leg length as a independent variable and torso length. Okay, however, it could be possible that for a taller individual, they can have both longer legs and longer torso. So you can see that there are two independent variables, leg length and torso length, but it could be possible that they are correlated, highly correlated, because there are individuals, um, there are other factors which which made them which correlated them. As you can see here, that it has been said that taller individuals tend to have both longer legs and longer torso. So you have seen here that it is a presence of strong correlation. Now next to it, how to identify this multicollinearity. Okay, so first we need to have a correlation matrix. Okay, examine where we have a correlation matrix to for a predictor variable, that which one of them are the correlated variables. High correlation coefficient close to 1 or -1 suggests potential multi-collinearity. So if we talk about correlation matrix, we go for variables. Okay, predictor variables, we examine them, and if they have if they have the value of 1 to -1, it could have a potential multi-collinearity. Next, we have VIF calculation. VIF calculation, we calculate it for each predictor variable, not the response variable. We talk about the predictor variable that we have, and if it has more than 10, or we it is suggested that there is potential multi-collinearity is there. Okay, so if multi-collinearity is detected, possible solution including is we just remove it. I mean, if it is there, we just remove it and or we could just combine the variables, or we could just add additional data to reduce the correlation. Okay, so that's how we would identify them, and if it is detected, we could just go for correlated variables or combining variables. This helps us in ensuring the stability and reliability of a regression result. Okay, so for the code, we could, okay, here is it. Again, uh, we have our, you could see here we have our modules. Then we read the data set. Okay, then we have our predictive columns, which are fuel type, fuel in L, and distance in kilometers. Okay, then we encode our fuel type, because obviously uh, it's a categorical value, and so we just encode the petrol is equals to 1 and diesel is equals to 0. Then we extract the predicted variable into their own data frames. Okay, we just predict and extract the predicted variables into their own data frame, and then we would create a scatter matrix to know that what we can you know we could understand from it. Like we right now have our uh, data set. Okay, so we just firstly see that what could be a relation between them. So first we have a scatter matrix, and so we would be just plotting it. Then we would add the constant terms. Okay, so we would firstly add the constant terms. Then again, next is our VIF calculation that we would do in values of x, which is our predictor columns. Okay, because we created the data frames here, and we would take the values from the range. You could see a loop here. Okay, then we would display it. So here you could see our scatter plot, which we have created to know our you know the predictor values. Okay, so here is the scatter plot. Next is our variance inflator factor that you have seen, the variables that could be seen, that's constant 95 point something, which is not that important. Then we have fuel type, but because fuel type is a categorical value, so we would not get a VIF for it. Fuel in L, which was 2.531101. So we could conclude that fuel in L and distance in km variables are not multicollinear, do not show potential multicollinearity because the values are less than 10, as the VIF values are less than 10. Next to collinearity, multicollinearity, we have uh, PCA, which is principal component analysis. So for principal component analysis, we just it is used just for reduction. Like if we have to transform a high dimension data into a low dimensional data, we would reduce it through our principal component analysis. It achieves this by identifying principal components such as direction of maximum variance, obviously, if which we only identify the principal components or the variables which have a high maximum variance. Okay, so PCA is commonly used for dimensionality reduction, visualization, noise reduction, visualization. Obviously, I mean in scatter plot and stuff, and noise reduction, which is said to be like, if it is not right now not useful to us, but it could be in the near future. Then feature engineering, where we encode categorical values. This efficiency depends on the dataset characteristics. Okay, how to apply PCA? Firstly, we standardize the data. Data is standardized to give all variable equal weight. Then covariance of matrix, PCA calculate the covariance matrix to understand variable relation. Then we have the eigenvalue decomposition, then selection, then finally projection. So next we could go for its code. Let me show it. Here we have the PCA principal component analysis. Again, we did the same thing in Gore. We read our CSV file for the data set, then predictor columns, then encoding, then extracting. Then finally, first thing we did was standardizing our X, which we created here, and performing PCA, obviously fit transformation. Then explained variance ratio that we created, that is the eigenvalue decomposition to explain the variance ratio. Then the cumulated explained variance. Okay, and then we plotted that. Okay, then the number of components in n component 2, which was number of components that we have to choose as the plot. Then fit p, obviously again we would just fit it. This would create our principal components, and finally we could just show it. Okay, so here you could find all our explained variants by the plotting, and then the data frame with PCA principal components. First it would PCI1, which we did before the variance comparison, and after the comparison. So you can see there is a huge change between them. Okay, so it got reduced to a much extent, a maximum extent. So through this we just concluded that this was we started with association rule, then we had our uh, association rule, and then we had um, confidence quotient criterion, then we had confidence difference criterion, then we had multi-collinearity, and finally we had PCA, which was principal component analysis. For this video, we only ended it. So thank you so much.